Consider a disk in which 3 bytes is used to address the disk blocks of size 2 KB. Calculate the size of the disk if it is equal to 3 by 4th of the maximum possible size. Here it is given that 3 bytes is used to address the disk blocks. So here maximum number of disk blocks which we can address is 2 power 3 bytes is nothing but 24. So 2 power we can address 2 power 24 blocks, and it is also given that size of each block is 2 KB. So maximum possible size would be number of blocks, maximum possible number of blocks, which is 2 power 24, and into size of each block. Size of each block is given as 2 KB. So if we simplify this, 2 power 24 into 2 KB is nothing but 2 power 11 bytes. So here 2 power 35 bytes, which is 32 gigabytes. 2 power 30 is gigabytes. 2 power 30 bytes is gigabytes. So here maximum possible size is 32 gigabytes. It is given that disk size is equal to 3 by 4th of the maximum possible size. So here size of the disk is equal to 3 by 4th of 32 gigabytes. So if we simplify this, 8 4s are 32, so 24 gigabytes. So here correct option is option. So 24 gigabytes is the size of the disk. So here correct option is option C.
Statements is /are true. Statement S1 is strict alternation guarantees progress. Statement S2 is Peterson solution suffers from busy waiting. Options are only S1 and only S2, both S1 and S2, and neither S1 nor S2. Strict alternation guarantees progress. This is wrong, because strict alternation means sending the process into critical section in alternatively. So for example, if P1 is trying to enter into critical section, for example, at that time if it not permitting, even though if other process is not there, then it will not guarantee any progress. So that's why this is not guarantee, will not give any guarantee of the progress. Peterson solution suffers from busy waiting. This is correct. Here busy waiting means a process who is waiting busy, that is who is in the running state and wasting the cycles of CPU, and that particular time of CPU cannot be utilized effectively. That is called a busy waiting, but the process will be in the running state. So that problem is there in the Peterson solution, where the process trying to enter into critical section, it is not allowed for critical section because other process is there in the critical section, or it is left in the middle of critical section. Only S2 is the right answer. CSMA-CD network of 200 meter length with no repeaters in between. Bandwidth of the network is 10 Mbps. Calculate the minimum size of the frame if the speed of the signal is 10 power 5 kilometers per second. We need to calculate the minimum size of the frame. The speed of the signal is 10 power 5 kilometers. Okay, so here we can do like this. Here if you take the number of bits required, the speed of the signal is what? It is 10 power 5 kilometers per second. So for 1 second, 10 power 5 kilometers. So 1 kilometer 1 by 10 power 5 seconds. 1 kilometer means 1000 meters. For 1000 meters, 1 by 10 power 5 seconds. So for 1 meter, 1 by 10 power 5 into 1000 seconds. So for 200 meters, because the network is of 200 meters length, it is 200 by 10 power 5 into 1000 seconds. We can convert into microseconds. It will become microseconds. So it will be 200 into 10 by 1000. So it will be 2 microseconds. So this is the propagation time. 2 microseconds is the propagation time. And then round trip time will be 4 microseconds. 4 microseconds is the round trip time. What is the bandwidth of the network given? It is 10 Mbps. So for 1 second, 10 into 10 power 6 bits. This is for 1 second. Okay. So for 10 power 6 microseconds, it is 10 power 7 bits. For 1 microsecond, it is 10 bits. For round trip time, it is for 4 microseconds. It is 4 into 10 bits. It will be 40 bits. Okay. So here it is 2000 meters. It is not 200 meters. So for 2000 meters, it will be 2000. So we will get around 20 microseconds is the propagation time. So round trip time will be 40 microseconds. So for 40 microseconds is 40 into 10. So it will be 400 bits. 400 bit means 50 bytes. So the minimum frame size should be the maximum number of bits which we can transfer in a round trip time. So 50 bytes, option C is the right option here. IP addresses in IP version 4. IP1 is 127.1.1.1, IP2 is 127.0.0.1, IP3 is 127.254.255.255, IP4 is 127.1.1.255. Which of the above addresses are loopback addresses? Option A, IP1 and 3, 1 and 4, all of this, none of this. So loopback address means to test the same thing whether it is working or not, to send some echo packet or else. Okay. So this will be normally the addresses of 127.0.0.02, 127.255.255.255. These range will be coming to loopback addresses. Any addresses within this range. So all the addresses are in this range only. So all of this. Option C is the right option.